Worksheet 13B, converting strain data to principal stresses. So just apply the generalized Hooke laws. A certain structural member is made of A36 steel, so they give us Young modulus E 29,000 KSI, new 0.32, and G, the modulus of rigidity 11,000 KSI. If they don't give up the problem, don't give us this information, you can go to appendix B of the textbooks. You can be able to find out this. In order to determine the state of strain at a critical point in a structural member, a strain process is used. So basically, it's same at worksheet 13A that we just did. When the structure was loaded, the following readings were taken and the corresponding state of strain were determined. So they give us the epsilon A, epsilon B, and epsilon C. So the state of strain here. So even this problem is given to you. However, you can be able to use this information to find out state of strain. So believe it or not, this is developed from worksheet 13A. So they give us that information, and in that worksheet 13A, we make up this state of strain. So that the first step, and we skip that part because we already do that in worksheet 13A. Now the question is determine the principal stresses and maximum in plane shear stresses corresponding to the state of strain. So it basically converting strain data to principal stresses. Remember generalized Hooke's law. Go back here. You see the process to do. So they give us the strain process, as you can see here. Data epsilon A, epsilon B, and now they already give the state of strain epsilon X, epsilon Y, and gamma XY. We have two paths. We'll get the same answer. The question asks the principal stresses and maximum in-plane shear stresses. Either to draw the Morse circle first for strain, and then generalize Hooke's law, which is that two equations to find out sigma 1, sigma 2, or you apply generalized Hooke's law first with these three equations, and then draw the Morse circle for stress, and you can find out the principal stresses and maximum in-plane shear stress, tau max. For this problem and the next problem, we use this path, which is draw the Morse circle for strain, and then we generalize Hooke's law, sigma 1, sigma 2, tau max to determine all of that here. So that is here. You can be able to use another one for practice with determine sigma x, sigma y, tau xy, and then draw the Morse circle for stress and practice both should get the same answer. So let's get back to the problem here, and with that we can continue with the strain, as you can see. So first, in this case, we draw the Morse circle for strain. Draw Morse circle. For strain. So first, to determine the Morse circle, we need to find out the sigma average for the center. So as you can see, the sigma average for our equal to epsilon x, epsilon y over 2, and from the equation we have the state of strain block, we have that the epsilon x 114 plus 100 epsilon y divided by 2. So we will have that equal to 207 micro inch over inch, and this continue with the radius equal to gamma max over 2, and we have equation in the node, which is epsilon x minus epsilon y over 2 square plus gamma xy over 2 square. Plug in here, so we can have epsilon x 314 micro minus 100 divided by 2 square plus 486 divided by 2 square. So from that we get this number about 266 micro inch over inch. So we can have Mohr circle information. We have AB center equal to epsilon average 0, which is 2070 micro inch over inch. And then we have radius equal to gamma max over 2. And gamma max over 2 is about about 266 micro inch over inch. So from there, with that information, exactly same as the one we did in previously, we can be able to draw the Mohr circle. So with that, we select the grid paper. It's easy to draw the Mohr circle here. Draw the Mohr circle to find out epsilon 1, epsilon 2, gamma max, so that we can apply the generalized Mohr circle, generalized Hooke's law to determine the principal stresses and maximum in-plane shear stress. So let's draw, insert the shape, insert the line. So we have the x-axis here and the y-axis from here. Go up there. So the 207. So let's get the center is 207 micro, and let's get one grid is equal to 50 micro. So we can have the center is 207. So about here, and you can see it is 50. So that is the epsilon average 0, that is 2070, that is the center. And the ratio 266. So it about more than 5 grid in here. We had the circle, and we can, from that we can be able to find out gamma max over 2. So let's put the here epsilon, and that will be micro inch over inch, and we have gamma over 2, also micro inch over inch for that unit for the vertical. And from that we can be able to determine the radius is 266. So it around here for the gamma max over 2, and go down vertically. Go down 1, 2, 3, 4, 5. So down here. So that is gamma max over 2. And now we can go ahead to put the circle. Move the circle. Move here in the center. Bit bigger. That we done for the more circle for this. Look marvelous, everyone see that. So from that marvelous, we have this point. This point is gamma max over 2. Already know. So that is gamma max over 2. That is 266 micro. Everyone know that one. And then we have the epsilon 1, epsilon 2 for sure. That is intersection of the more with the horizontal on the right. It will be epsilon 1. And the other, it will be epsilon 2. The other side within the left, we have epsilon 2 here. We can be able to use the ruler to measure and find out epsilon 1 and epsilon 2 directly from the Morse circle, or you can be able to use the equation epsilon 1 equal to epsilon average plus radius gamma max over 2. So it means 207 plus 266. So we have epsilon 1 about 473 micro inch over inch. And epsilon 2 equal to epsilon average minus the radius gamma max over 2, 207 minus 266. So we have epsilon 2 around minus 59 micro inch over inch. And we can also find out the locate the point on the circle that define the state of strain for the x plane and y plane. And if you have the x, epsilon x equal to 314, and let's move to here, review that again for the problem. State of strain, and you can see there, epsilon x is 314 micro, and gamma x 486 micro. On the positive x plane, gamma xy rotate, make the yellow block rotate counterclockwise. That's why gamma xy in the Morse circle is negative, and in the Morse circle it have to be gamma over 2. So 486 divided by 243 micro. So as you can see, in positive x plane we have epsilon x 314 micro, and gamma x over 2 is negative 243 micro. And for the y plane, it will be 100 and plus 243 micro. So go back here, we can determine the x plane, and that x plane actually this point, and you can see, and the point x here is 314 from the axis 314, and then negative for gamma over 2 243 micro inch over inch. And of course the opposite will be y, this point here, that is the y plane, and the y plane is equal to y plane, as you can see, equal to 100, and then 243 for gamma over 2 micro. And then we can draw the diameter, connect X and Y, and it should be go through the center. Go through the center. So they have to be on the straight line. And then we already have XY plane. XY plane. We can be able to define, for example, here this angle from the positive X plane to epsilon 1, the horizontal you will have that is 2 theta p1, and from that positive X to here we have 2 theta p2, and to that theta p2, whatever you measure from your protractor, it divided by 2, then it will be clockwise, and theta p1 is counterclockwise. And then you also have the angle for theta s, so this is 2 theta s1, and we also have that is 2 theta s2. Theta s2. So bottom line, we finish the Mohr circle, and we have epsilon 1, epsilon 2, and then use the generalized Hooke's law. We can find out the principal stresses and maximum in-plane shear stresses, which we will discuss in the next video.